Hi everyone, this is chemistry for January 21st, 2019. I'm sorry we're not meeting today. I'd like to hear about your J term and your Christmas break, and we've got lots to dive into so we don't get behind. I'm going to start with a little talk about lab reports. I have modified this handout, which I can post to Canvas when I'm done, and I want you to print it out and actually read it. Couple things that I want to highlight. First of all, font size. Don't print out your lab report with a massive font size, massive being anything over 12. And in fact, 12 is looking pretty big to me, depending on the font you choose. So stick to 11 or 12 depending on your font. Headings can be a little bit bigger, like size 14. The lab report number that goes right here is not like the number of labs we've done this year, like lab number 4. The lab report number is the number from the module of this, this lab that we're doing this week is going to be lab number 8.1. So that means module 8, experiment number 1. Then I want to talk about data. I want you to use a data table actually all the time. Like at first we just said if applicable, but I think only one of you, maybe two, use a data table regularly. So I'm just going to say every time put your data in a data table, okay? So you can, make a chart with boxes. You can label on the side. This is when we did it this way. This is when we used 30 grams of baking soda. This is when we used 60 grams of baking soda. This is when we used 90 grams of baking soda. And then you go to the next column in your chart and you put, these were my observations for that first time with 30 grams. These are my observations for the second time with 60 grams, and so on. So data just needs to be in a clear way to show what happened during your experiment. The last thing I want to really hit home is the idea of a conclusion to your lab. So your textbook is notorious for explaining everything in the half page or so that comes after the lab, and it explains the lab, and to me over explains it because I want you to kind of wrestle with it and figure it out. So try it on your own, figuring it out, and if you can't, then read that half page after your lab and figure out how does this lab relate to the unit. So the point of the conclusion in your lab report needs to connect what the lab was with the ideas that we're studying right now. So is it showing that, water expands when it freezes, and that's different than most other substances because most other substances shrink when they freeze? Is it, showing that this reaction is this way because of this principle of combustion or of, whatever it is? So connect it to the bigger picture. Answer the question, why did we do this lab in this unit? Because if you just have like a 1-sentence, 2-sentence conclusion, well, this happened like this because blah, 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 then that is not a sufficient conclusion, okay? The conclusion needs to be wrapping it all up. What did we learn? How does this relate to the module? How does it relate to the concepts? What concept is this bringing out, okay? So that's that, and I have a new grading rubric. The other big change is that lab reports are going to be worth 15 points each for this semester. Last semester I made them 20 points, and every time I just felt like I was like giving away free points. I think 15 is a more acceptable amount for the amount of work that goes into it, given that tests are 50 points, homework is 5 to 10 points per week. I'm increasing that. It was first semester 5 points every week, but I realized that the study guide and practice problems are a lot more work, and so I'm going to give 10 points for the weeks that you have a study guide and practice problems to do. That I will check every class period. Have you done it? You're going to get the points or you're going to not get the points, okay, for homework. So just wanted to update you on those changes. And you can print out the grading rubric because it kind of summarizes what I have there. So I'd really like to see also you tighten up your lab reports. Some of you are already doing that, but others of you, if they're really long and conversational, you need to shorten them up, make them just short and sweet. This is, explain everything clearly, but just don't go on too much. I am going to jump right into a review of significant figures. This was on your final, and some of you continued to struggle with it. So we just need to nip this in the bud, figure out sig figs, and move on with our lives, right? But every problem that we solve relates to sig figs because we need to know how to report our answers when we have a mathematical type problem. So let's just talk about them for a minute. Okay, here's some different scenarios. So 9,341. How many sig figs? Okay, that's the easiest case. Each digit is stating a level of accuracy. There's no zeros for placeholders, so there's no confusion. If it's a non-zero digit, it counts. So how many does this one have? 4. All right, let's look at the next one because zeros are where we get tripped up, okay? So here, this one has 4 zeros, but they are all to the left of my non-zero digits. So in a decimal situation, if the zeros are to the left, they are placeholders. They are telling me how tiny to get or how big to get. So they are not considered significant. So just my non-zero digits, 1, 2, 3. So here's my 3 sig figs, okay? What about if my zeros are in between? So I've got 120.043. If they're in between non-zero digits, do they count? Yes, they all count. So I've got 1, 2, 3, 4, 5, 6. I've got 6 sig figs here. All right, what about here? What if I have a 0 to the right of a decimal? Then that is showing me a level of accuracy. That is showing me that it's 510 and no tenths. So it's been measured very precisely to the tenths, and it's been found to have 0 tenths, okay? So it counts. 1, 2, 3, 4. We're trying to measure accuracy. How well was this measured, okay? What about this situation? It looks like the same number, 510, but it does not have a decimal. So we don't know, was this just rounded? This being a 0 here, if it was 511, we would know it was measured to that tens place. But since we're have a 0 here, we don't know. Was it measured exactly to 510, or was it like 512 and then somebody just wasn't very accurate in their measurement? So we can only give this 2 sig figs. Okay? If you want it to have more, then I use this, and I don't know if I made this up or where I got this from, but in my class anyway, if you put a period there as a decimal with nothing after it, I consider that decimal to be meaning that it was measured accurately to this place, okay? So I count that as 3 sig figs, okay? So does this make sense? Zeros are what trip us up, and if they're to the right of my non-zero digits, if there's a decimal, they count. If there's no decimal, they don't count, okay? If they're to the left and there's a decimal, they don't count. If they're in between, they always count, okay? You've got to nail this. You've got to get this down. If this does not make sense, then go to YouTube and type in their significant figures and watch a couple videos of some people maybe explaining it a bit differently than I am. Go back in your book, but you've got to nail this, okay? The second thing I need to review with you based on the final was scientific notation. Okay, so we're just going to use these same numbers and we're going to put them in scientific notation. Some of you, you get it. Some of you, you're still struggling. So let's just put these into scientific notation, okay? Scientific notation, step 1, write the first digit, the first non-zero digit. So my first non-zero digit is 9. Step number 2, write a decimal. Every time. You're never going to write 9-3 decimal. You're never going to write 9-3-4 decimal. You write one non-zero digit and a decimal. Then everything else comes after it. So in this case, we're going to have 341. And so you put everything that's significant after it. Okay? So if there's zeros that are significant, you put the zeros. If there's non-zero digits, you put the non-zero digits. Okay? But then we have to figure out, when we're done with the scientific notation, it needs to have the same value. So let's say I've got a lot of bags of M&Ms, okay? And I have my kids count out M&Ms and we make piles of hundreds and whatnot. And we end up saying that there's 9,341 M&Ms. If I write it like this, or if I write it like this, it needs to mean the same number. It's the same exact number. It's just written in a different way. So I have to figure out times 10 to what power will give me that same value. So when I multiply it out, I end up with the same number. So if my decimal right here is here, I had to move it 1, 2, 3 spots to get the decimal to be after the 9. So do you see how if I were to multiply this by 10 3 times, so times 10, times 10, times 10, it's the same value as this. It's the same number of M&Ms. It's just writing it in a different format. Okay? Let's work on this one. What's our step 1 for scientific notation? Write my first non-zero digit. Write my first number that's not a 0. So I'm not going to write this, 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 or this. I'm going to write a 5. Then I'm going to write a decimal. Then I'm going to write everything that comes after it. 6, 4. So I don't need all those zeros, okay, that came before. They were just telling me how far out to go. So times 10 to what? Remember, we want to end up with the same value. Now, this is a very tiny number. So let's say it's the number of grams in, this sample of sodium chloride or something like that. A really tiny amount. So I need to multiply by something that's going to mean the same thing as 0.000564. So this time I'm moving the decimal the other way. So for me to get where it is here back to the original way, I have to move it left 1, 2, 3, 4 times in the smaller direction. So that's going to be -4. Okay? So this is the same amount. It'd be the same amount of grams if this is what I'm measuring of my sample. Okay? It's just written in a different way. All right, how do we do this one? First step, write one number that's not a 0. 1. Second step, write my decimal. Decimal. Okay? Third step, write everything relevant that comes after it. So 2, 0, 0, 4, 3. Then I write times 10. Sorry, I'm going to have to jump down here. Now to what power? I want it to mean the same thing. I want it to mean the same amount, okay? So let's say this is the temperature in Saudi Arabia, 120.043 degrees Fahrenheit, okay? So I want it to mean the same thing. So I want this to get bigger once I multiply it out. So I have to go from, that's where it is in my scientific notation. I would have to move 2 to the right to get it to mean the same thing. So times 10 to the second power. So if I take 1.20043 times 10, I get the same number. All right. Step 1 for the next one, write my first number that's not a 0. Then write a decimal point. Then write everything that comes after. Now, this was showing me accuracy, so I'm going to keep the zeros because they were significant. Keep everything that was significant. So 5.100 times 10 to what power? Well, I've got the decimal here in my scientific notation. I would have to move it over 2 times to get it to be the same number. Okay, so I kept the zeros because they were significant. Now, what about this? Okay, this only had my 2 significant figures, remember? Because there's no decimal telling me how accurate it is. So I'm going to write 5.1 with no zeros after it because this 0 is not significant. Not significant. Okay, so it doesn't get put in here. Only significant figures get written here in the scientific notation. So then this is where the decimal is in my scientific notation. I'm going to have to move it 2 times over to have the same value. Does that make sense? So we're not changing the value of the number. We're changing the way it's written. I hope that helps. I'm going to stop this video because I'm having problems uploading long videos. So I'm going to stop this. Make sure to watch part 2 where we're going to get into our content now for Module 8, Stoichiometry.